Good afternoon, everybody. Today we're uh, covering the sixth session in the build on process. And the focus here is the schedule says that we've finished integrating all the parts and we have a functional uh, text finder. You may or may not be there. If you're not there, wouldn't be a bad idea to try to catch up. And I'm open at the end to any questions about that if you have some. Okay, so so here we are in session six, and the last time I asked about whether you thought it was valuable to do the regex and a parallel search, and everybody seemed to think that they wanted to go ahead and do that. So that's my plan, and I'm going to talk about regular expressions today, and if we have time, a little bit about parallel search. So let me just pull up my solution. So here, uh, the solution code is in the BuildOn repository in BuildOn 5 solution. And I'm going to pull that up in Visual Studio Code. I made some last minute changes this morning, right up until about lunchtime. It all seems to run okay, but it's always a dangerous thing to do, especially just before a presentation, to make last minute changes. But if you're interested, we can talk a little bit about what's going on. So uh, this is a TextFinder library, and I created an executive object. That isn't necessary. You don't have to do that, but I chose to do that, and its elements are the command parser and the dirnav. And dirnav is templatized on Finder, which is a text search, and Finder is templatized on genout, which is the display. So because I'm naming all these things, I have to import. So I'm importing dirnav here. I'm importing text search, which holds Finder. I'm importing display, which holds genout. I'm importing command line parser, and then using standard path and path buff. So, and if you look at the cargo toml, that's where all these are established. I couldn't, those uses would fail to compile if I didn't put these here. But so now let me get back to okay. So executive in his new function simply initializes CP as the command parser, and command parser has a new function, so he's just initializing a command parser. So the executive owns the command parser and owns dirnav. He doesn't own Finder, he doesn't own directory, okay, but he owns command parser and dirnav. And this is setting up that flow model, from input to output. And the process command line, I parse it, and that may return some empty values. And so if I say in my command line /h, meaning I want to hide the directories, I normally don't supply an attribute, so it comes up after parsing as /h with an empty vector of values. And so anytime I have an attribute with an empty vector, I just set it to true, because that means to me, my model is that things like H and S, S for recursion and so on, that can do that. And I look for an H parameter. If there's an H parameter, that means help, and it ignores everything else. It just spits out a help message and then returns false. And your program, the model is your program will quit. I'm not sure that my test uh, 2 does. Mike, you might remind me to check that. But the model is that if there's a help there, then everything else is going to be ignored. Just spit out a help message. Set defaults. What this does is the this library has defined a set of defaults that make sense for almost all applications. But there's a few defaults that it can't, from application to application, it can't decide what to do. But whatever it can set, it sets. And what set defaults does is, if you haven't entered anything on the command line, it'll insert something. It'll insert a key and a value. But if there's a key there, it just returns. If there's a key there, that means that the command line entered that, and you don't want to replace what the command line entered with a default. So default's just, if there's nothing there, I'll set the default. If there is something there, I just return. And I have a get parse that just returns a attribute. And if get first is V, this stands for verbose. If that's equal to true, then I print out the command line, and I print out a list of arguments, and I print out the parsed attributes that, anything I have so far. And if I have a P, that means I've entered some parameters, some patterns, then I just push those patterns into dirnav's pattern store. If dirnav doesn't have any, if dirnav's pattern store is empty, it just returns everything. So it's kind of odd. The more we add, the more we return, except that if we don't add anything, we return everything. Just a simple way to do it without a whole bunch of logic. And set text in Finder. So if I have a T, then I'm going to set the text, and the text needs to be set in dirnav, because I don't want dirnav exploring a whole bunch of files that we aren't interested in. We're just going to throw away. So I'm sorry. That's not what I'm doing here. Back up. So dirnav.getApp is returning me the text search. And in text search, I'm setting the text to search for. And as of this version of TextFinder, I'm only returning the first one. You could have entered 2 or 3 different texts, and I'm just returning the first, which makes sense because we're going to go on and use in the next extension, in the first extension, we're going to use regular expressions, and you only need one to get a whole bunch of different search types, text types. So anyway, that's what's happening here. And then I'll let out get dirnav get app, and now I'm saying to get app. I'm saying to dn.getApp returns the application, which in this case is text search. And then that application has to implement getApp, and that's going to return the output. So if your output has some arguments, has some functions that you can supply to change the way it operates, then that gives you access to it. And so here's apply hidden attribute. Here I'm going to go to the output and say, hide the unmatched. I wanted text search to send everything, both matched and unmatched, to the output because I wanted to be able to choose which I was going to show. In fact, I can choose at runtime. I can do both if I wanted to. So that's why I did it that way.
Professor,
Yeah,
can you please repeat why we have get app twice?
yeah. So Durnav's get app returns TextFinder.
Okay,
It returns Finder. And now I'm calling on Finder get app, and Finder's app is the output.
okay, okay.
That's the
Got it.
penalty I'm paying for this flow model because the executive doesn't own all those parts.
Okay, okay. Got it, Professor. Thank you.
Yep. I could have, in fact, uh, had the executive own them all and then assemble them. Uh, this seemed a little easier to me. If I went back and tried it the other way, I might decide no, it was really easier the other way. But anyway, that probably, Mikhail, that probably deserves a little more comment here to say what's going on. The get app. So if you would, just after the meeting is over, just go to Discord and send me a little message about adding a comment to get app.
Sure, Professor.
Great, thanks. Okay. Apply show all attribute both marked and unmatched if somehow self.getA. So on the command line, I'm setting A. If else is empty, show all else equals true. Okay. So uh, normally I don't. All is what's really going on is I'm hiding stuff, but if I say all, even if I have the hidden directories, what that means is that I'm not going to show directories that have no match, that have no file patterns, files that match the pattern, but I will show, if I set all, I'll show both the files that have the search text and files that don't have the search text, and I'll mark them that way so you can see which is which. But if I don't set all you ever see are the files that have a match.
Professor,
Yeah,
can I ask a question? So like 994,
yeah.
like why we have like a star in front of the true? I know like the true is like a string literal, so the type is like
So this is a
reference
to a
static.
string, and so now the star says, I want you to compare to what's laid out in that part of stack memory.
Okay, so what's the type of the out?
Outs is a vector of standard string.
Oh, okay.
Okay.
So the true is like a reference static
So
star.
it's been a while since I've done this, so I got to remember. Um,
I think
so hang on a minute. So outs is so get A is returning an option, and let's see if I can force it to tell me. I'd have to go back and look at what that option is.
okay. I
Okay.
think yeah, in the above line there is a assignment. Am I right? Like there's a maybe in
This is
line.
not an assignment. This is a matching operator.
No. It's on line above line like 70. Just
Above
go up.
line 17.
Yeah. Oh no. 70.
70.
Oh no. I think. Oh, I got it. It's not. I got it. It's not like a assignment. the line 90, 80, 87, and also like 94. So these are
Those are
comparison.
comparisons.
Oh,
Yeah,
comparisons. Oh,
those are
gotcha.
comparisons. And this star is here to make the comparison types match.
Yeah, I think there is something called like
I think what's happening is when I do this, that's implicitly calling a two, like two string to make it match that.
yeah. I gotcha.
Okay.
Gotcha.
So I could have said dot two string, that would have worked. And I think this is just implicitly, essentially, causing it to build that string.
Yeah.
Okay.
Yeah, that makes sense.
Why don't you also put a little note about, line 87 on the Discord server, and I will double check that to make sure that's exactly what's going on.
Okay.
Okay?
Okay.
But
Okay.
I'm pretty sure that's what's happening. That we're invoking one of the traits, the from trait, so that this is expecting a string, and so this is invoking the trait that turns this uh, um, SPDR into a string.
Yeah.
Yeah, using a from trait. Okay. Okay. And this is all kind of repeated. Apply debug. So debug is a special formatting for the output, and so that's why I grabbed the outs early up above, because I'm going to use them in several places. So this just changes how the output displays. Just adds a little bit of more content to the output. GetDirs is returning the number of directories we processed, and getFiles returns the number of files we processed. So there's basically little counters every time dirnav calls doFile and every time dirnav calls dodir. In those functions, there's counters that are being incremented, and all these guys do are just get those counts. And that's at the end. I'm going to print out, how many files and directories I processed.
Professor, I have a question. I vaguely remember you mentioning something about vectors not being indexed. Not being able to access them through direct indexing
Oh, you can
for
index
memory
vectors.
safety.
You can index vectors.
Okay, so for the
Uh,
memory safety features, I believe we said that there was something that doesn't allow you to directly access any random element of a vector, but you have to use an
no,
iterative.
what happens is you can't move out of a vector. And the same thing is true of an array. You can't move an element out of the vector, because that would leave a vector with some valid elements and some invalid elements. So it won't
Okay.
ever let you move out of a vector.
Okay.
And it does the same thing for an array.
But it allows you to read just fine.
Allows you to read just fine.
Okay.
It was
Thank you,
strings
Professor.
that you were talking about that couldn't be indexed, Doc, in that conversation. Strings that couldn't be indexed.
Oh, strings can't be indexed.
Yeah,
But I'm pretty sure that we also had that conversation about, not being able to move out of a vector. But strings can't be indexed either, just because the size of a character varies from 1 to 4 bytes. So you have to index them. Yeah, you have to iterate them.
Thank you, Professor.
Yep. Okay, so there's here's a place where I want to return a string from what I'm trying to get is the first element out of the value. Okay, remember that my command line parser is a hash table of strings and vectors of strings. And if I want to get I want to get a string from that first vector, from that vector of values. Okay, here I want to return it by value, and I can't move out of, this is a move operation, and I can't move out of the interior of a vector, but I can clone it, and I can move the clone. And that's what I'm doing here. And it wouldn't surprise me that it was right here that we got into that conversation, Vishtap. Okay?
Yes, Professor.
Okay. So get first returns a clone of the first string in the vector. And if it's empty, I just return an empty string. Just so I don't have to have a result and peel back all the, result processing. A get parser allows me, my client, to get access to the parser. I'm not using it directly anywhere in this example, but that's why it's there. I have two things. My library is going to call a set of defaults that make sense for almost all applications. Set the current path to dot, set the path to the current directory. Do recurse, do hide the directories, do emit, the verbose emits a little bit of information at the beginning, set the text to a blank so that all files will succeed. This just, the first time it finds a space, it succeeds. So it's an efficient way, you don't do a whole lot of searching. Debug is false and all is false. And for almost all programs, these make sense, so I just apply them here. But I might want to add or change some of that in my client. My client might not like exactly this set. He might want to add to the set, or he might want to change something in the set. And so I have two functions that let him do that. This first function, set attribute item, will if the attribute doesn't exist, it calls set default to create it with that attribute and that value. If it does exist, it just pushes this value onto the set of values that key already has. Okay, so my client at any time can add another attribute. Now, set default, which is I'm calling here, if the attribute, so I call set default on the on the command line parser, and what the command line parser set default does is, if there's already a key, it just returns, doesn't do anything. Okay, and so in my set default, I want to do the same thing. If the attribute contains P, a new pattern, okay, however, I'm add the patterns to the navigator, because the navigator is the guy. I always want my navigator to use the patterns because I don't want him sending me a whole bunch of files that I don't need. So I push into his add patterns. He's expecting a path. So, and my val is just a string, so I convert the string to a path and push it into dirnav, and so now dirnav will use it. And if here get is returning an option, so I'm peeling out that option. If the command line parser has a verbose in it, then I print out if vec0 equals true, so if the verbose is true, not false, I print I added this key value. So in my set default, I'm going to print out that I added this key, and it also will happen here in set item because he's calling set default. I'm going to print out the fact that I added that, just so the user knows. And then I have a help message I put together, and that's it. That's the whole thing. So here's, was there a question?
Yes, Professor.
Yeah.
I was just wondering, what if we want to set the recurse to false? In that situation, that function wouldn't be able to handle it, right?
So what happens here? This function will. So because what happens here is instead of saying set defaults, what I'll do is I'll say here set attribute item, and then I'll set s to false. Okay. And now what happens is this does nothing, but if my value, if I can successfully get the value, then I push it onto that set of values. And so, you know, he's already set to um, recurse to false. So this will do nothing. Now I can get this attribute's value, and the value is, huh. I think you just pointed out a bug. Because what will happen is now I'll have a vector with both true and false here, and that's wrong. So
Right.
good for you.
We are just appending the new key value pairs
Yeah,
into
I'm just
what already
appending it
exists.
to the end, and I don't want to do that. And this is a case, so I need to figure out a better way to do that. I could do a set attribute item exclusive, and then just replace it instead of pushing it here. Just write it into 0. Okay. For patterns, I don't want to do that, but now the question is, gee, I'm getting an awful big interface footprint. Is there a better way to do that? So do me a favor and add to the to your Discord message to me that I need to look at line 135 in the library because it's not handling recurse false properly. Okay,
Sure, Professor, will do.
thank you. Definitely is easy to fix, but the obvious way to fix it is to add another function to the interface, and I'm not really sure I want to do that. I'd like to find a cleaner, simpler way to do it, but anyway. So now let's look at test 2. Test 1 didn't use an executive, test 2 does. So now I'm using the executive and let executive equals new. I process the command line, and if that doesn't succeed, it'll return. For example, if there was an H on the command line, then it would then process command line returns false because it wants you to quit. Otherwise, here I set attribute item p.rs. So I'm adding, I'm adding p.rs, which, let me go back here. Which I don't have. I don't have any patterns here, which means it'll send every single file. So this is correct. So now what's happening here is I'm just going to return RS files. And then I attempt to start the navigator. As long as it starts, it runs. And now here's where I'm calling get files and get dirs just to print out the files and directories that we process. So let's just run it. Okay, so now I've got text, and now let's add, so let's just run that. So I thought maybe I would pick up some other files. So, oh yeah, no, it's so now let me comment this out. So it's just giving me the RS files. So let me comment this out. And now let's run it. And now I'm getting other stuff that are not RS files. Okay, I'm getting a bunch of other junk. So we saw that this was supplying that RS attribute. And we can see if we go up and now, these are all just RS files. If we go up here, so what we originally parsed out was this, and then we added this PRS, okay? So there was no pattern here. There's a path, but no pattern. So we added the pattern RS, and now we're just getting the RS files. So that's the way it works. How do I get you back? I minimized you. Here we go. So now that's my solution. I'm going to fix that one bug that Mikhail discovered, and I'll think a little bit about the interface. The obvious fix is to add one more method to the client's interface. I may decide to change things around a little bit. I don't know. So sometime, maybe middle of next week or something, I'll update that solution. But for now, it's here. It works. It does what it's supposed to, except I can't set my recurse to false. Yeah, you can see it's recursing. So I can't set it to false because of that bug that Mikhail pointed out. What I did was, instead of replacing the true with false, I added false after the true in my vector. So, alrighty. Anyway, enough of that. So that's there on the the BuildOn. So here's BuildOn solution 5, and that's where the code we were just looking at. What I did was an hour before this meeting started, I just cloned this on this machine. This isn't my production machine. I build stuff on another machine, and so I pushed it up to GitHub, and now I just cloned it an hour ago, and so that's what's there. Okay. So, any questions before we begin Regex? So, step 5 has us add Regex to text search. And it's really quite simple. I'm not giving you any helper code or anything. There really isn't a whole lot of stuff you got to do. Um, in in Finder, you're simply going to replace the string find with a regex is match. You know, it's a little more than that, but not a whole lot more. And I've got references here. There's a regex crate. So here's the first time we're using a crate from crates.io. So this is on, this is the documentation for crates.io. And I've gone out of my way not to use any crates. I typically don't use crates if I don't have to. If I can implement it myself pretty quickly, I will. And the reason for that is when you use a third-party crate, you're going to build up dependencies. And it can happen very quickly because regex uses a couple of other things. I don't think those other things use anything else, but some crates, you know, the crate will depend on 3 things, and each one of those 3 things depends on 3 other things, and you get this combinatorial explosion of dependencies, and meaning your build time just goes into the dumper. So, you know, once you've built it once, it's nicely cached, and so it's not a horrible problem if you use a crate that has lots of dependencies. So the first time you build it, you go out and get a cup of coffee or make a pot of coffee or something, come back, and then all the subsequent builds are quick because it's caching all the, anything you didn't change, it won't rebuild. Now I'm going to go to my Rust bytes. I created a Rust byte for regex. And I like this quote. Regex has regular expressions have the reputation of being not hard to use, but often surprising. You don't get the result you expected. And you'll see a little bit of that here in my demos. So, you know, this guy made this comment. Some people, when confronted with a problem, say, hey, I'm going to use regular expressions. Now they have 2 problems. Okay. So, but what you'll find is regular expressions for the simple things are really simple. As they get a little more complicated, it gets harder. For things, when we use, when we supply a regex to TextFinder, they'll almost always be really simple things. I want to find all the files that have both a struct and a main. Or I want to find all the files that don't have a comment. Don't have an opening prologue comment, and you can, so they're not hard to do. Okay, so here's a little, so we're going to use this library, and here's a little example. Let's just pull up the Rust Playground code. What happens with Rust Playground, if you put too much code in there, it'll sometimes fail to build because you run out of time. They only let you run for, I think it's 11 seconds or something. And if the playground is busy, if you do it in the middle of the day, the playground is busy, takes longer to build stuff, then a lot of times it'll fail. But anyway, I have a function check, and all that's doing is I'm passing in a string that's my regular expression pattern and the text I want to match it against. And then I build a regex, and this is a compiler. This regex, what it's doing is it's taking this pattern string and it's compiling it into a state machine. and then is matched just uses that state machine. And there's a bunch of other functions which we'll look at that use the state machine. So this is just checking if the regex matches the text you passed. And then show the regex test. So if check, I'm doing the check, print out, it matched the text, otherwise print out, it didn't match the text. And now I'm just going to do some simple exercises. Let re equal regex new. I'm building one. I'm not going to use check for this particular one. And I'm setting up here, I'm looking for 4 digits, a hyphen, 2 digits, a hyphen, and 2 more digits. I stole this from the crate. This was an example on the regex crate. And he's just looking for a date in year, month, day. So it searches that's true, and it won't print out anything. Okay, let's run it. So ABC matches text 123 ABC 987. Regex does not match 123 000 987. I took out the ABC. So here's this assert passed on this date, and now I'm just running my own. It's not printing anything out. It's just silently. If it doesn't panic, then this passed. And now I'm testing, this is an obvious match, and this is an obvious mismatch, and that's exactly what we see. Now, R just means this is a raw string, and a lot of people use it automatically because otherwise, if you have a backslash and you want to treat it like a backslash character, then you got to use a double backslash. But with a raw string, it doesn't interpret anything. So anyway, here I'm looking for one or more lowercase characters from A to Z. That's what this is. Or 2 uppercase characters. So 3 ABC matches. So 4 A ampersand stuff doesn't match because I don't have any lowercase characters and I don't have 2 uppercase, so it does not match. But if I add another uppercase character, now it matches. And if I just put in 1, 2, 3, there's no digits here, and so it should fail, and it does fail. So, just a simple little demo. Just to give you a flavor, the idea of what's going on. So this crate, regex version 1.4.5, is available in crates.io. Okay. And they tell you, here's how you use that crate in your program. So in your text search, you want to, in its TOML file, you want this dependency, just like that. And you don't need this now. You need a using statement. If this was before Rust 2015, you'd have to have this, but otherwise you just use regex. So you need this, and you need this. That's all you need. So regex is a processor of a regular expression. It compiles one into a state machine that can check if you got a match. It can return capture groups. Anything surrounded by a paren that doesn't have a question mark at the very beginning is a capture group. It's a capture group that returns something. everything in the regular expression, if you've got parens, they're a capture group. If you have a question mark right after the opening paren, it's a capture group that doesn't capture anything. It's just like saying don't do this. You can split text based on capture groups. So if you want to grab different parts of the text, you can do that by being very careful how you set up these capture groups, and you can replace text. I'm going to illustrate these first two. I'm not going to illustrate these second two, and let's just call up the, before I do that. So now here's what Regex looks like. So it's going to use this is a match iterator. It iterates over, this is a match type. And what the match type holds is string and a start position and an end position. So it tells you in the string, you matched from here to here. And then its functions are new, and you supply it with a pattern string, and it returns a result. So you gotta parse the result. Cheapest way to detect a match is just to say is match, and you just add the text. So you've compiled the regex, and now you just call is match with the text. And it's these two things that you're going to do in build for the next session. Find returns the start and end of the first match if it exists. So it returns an option of this match. And so if it didn't find a match, it'll be none, but otherwise it'll return the first one. Find iter returns an iterator that returns all of the matches from first to last. Captures is weird, as we'll see. Captures returns an option with the capture data, and we'll see what that means in a minute. And then there's an iterator that allow you to iterate over the captures. And then the split and replace all, and you can play around with some of them if you want. So here's my example that's going to exercise a few of these functions. Again, I'm not exercising all of them, but let's go down to the, there's a lot of code here, so this may not build. We may have to look at the, oh, it did. Okay, good. So use regex, and match and captures. So I have this function catch, which is just like I did before, but now, I have the pattern string, the text string, and whether it matched or not. And so if the bool is false, if the predicate is false, if it's true, it just says I matched the text. Bear with me just a second. Okay. Says I matched the text, and if not, it tells me I didn't. Range, here I am I'm gonna supply it with an option match, and so I'm just to see whether this is none or not. If it's some, then I print out I found the pattern in the text, and it matches from this start to this end. Otherwise, no match. So let's look at what. Well, let's go on for a minute. So, and then range iter, now I'm going to iterate over my captures. So let's start out with the match. So here I have a pattern, a lowercase character repeated either 3 or 4 times at the end of the string. The dollar says the end of the string. So 12 C, D, E, well, that's the end of the string, and there's 3 of them, so that should match. 12, C, D, E, F, G finds 3 at the end of the string, so that should match. 2 at the end of the string doesn't match. 2 and then a digit and then a character doesn't match. And CDS doesn't match because I'm trying to match characters between A and Q, not any lowercase, but just the lower cases between A and Q. And so here, S is beyond Q, and so this shouldn't match. And that's exactly what happens. So this matches CDE, matches CDEF, doesn't match CD, doesn't match CD3E, doesn't match CDS. Okay? Cool. Now I'm going to test find. My pattern is ABC, and I build a regex for that pattern. Now I have 1, 2, 3, ABC, 5, 6, and I call find, get back this match, and I pass it this range function with a pattern, the text, and this, and it's just going to pull out the op and tell me what happened. So here's test find. Found the pattern ABC in text, 1, 2, 3, find the pattern ABC in a text, ABC, match from 3, 0, 1, 2, 3, 4, 5, and 6 is the one after the match. So this is a closed open interval is what it's returning you. Cool. Let's try test find iter. So my pattern again is ABC, and now I've got a string with two ABCs in it, and so I should get 2 matches. ABC found match in 3 to 6 and found match in 9 to 12. You with me, Kyle, or have I put you to sleep? Does that make sense?
Yes, Professor.
Nooper? Maybe. Okay. Zing, make sense? We can't
Sorry, I
hear
was
you.
on mute. Yes.
Yeah, you're on mute.
I'm muted.
Yeah.
Sorry. Yeah, I think it looks, the code looks good to me. I just need some a background study about the regex,
Sure.
syntax, grammar,
Yeah.
those kind of stuff.
Yeah, we're going to do a little bit of that in a minute. So, not exhaustive, but there'll be plenty for you to work on after this is over. Now, test captures. So here I have 1, 2, 3, ABC, 4, 5, 6, D, E, F, 7, 8, 9, and now I have my pattern. Here's 3 lowercase, 3 digits, or 3 digits, 3 lowercase or 3 digits, 3 lowercase or 3 digits. I could have said just digits here and then lowercase here and digit here, but I wanted to be able to swap these around if I wanted to. So this should match. And sure enough, test captures. Now what captures does, the 0th one returns everything. Okay, but now you get the individual ones here. So captures 1, okay, so so what I'm doing here is I get this captures and unwrap it, and now I'm just stepping through it. 0 to caps.len captures, and I use a get caps.get for that I to get the match for that. And so what I have is, for 1, cap 1, 2, 3 from 0 to 3. 1, 2, 3 from 0 to 3. I have ABC from 3 to 6. ABC from 3 to 6. 4, 5, 6, 6 to 9. D, E, F, 9 to 12. 7, 8, 9. 12 to 15. So it all worked. But look at what doesn't work, and this really surprised me. Can you guys see that? It's kind of dim. I tell you what, I'm going to uncomment it for a minute so it's a little darker. So capture doesn't work well with repetitions. Let pattern equal A to Z 3, 0 to 9, 3. That's what we had before. So now I just want to take this capture group and repeat it 5 times. That's exactly what I did here. But this fails. This just gives me the last capture. Why? I have no idea. The only thing I know is that this regex crate, I don't know whether that's supposed to work, whether regular expressions theory says it'll work, but for this crate, you can't apply repetitions to the capture group itself. You can't repeat the capture group with a shorthand. You gotta write it all out. This didn't work. You know, I tried several variations. None of these worked. And that surprised me a little bit, irritated me a little bit. So, and I don't know. I looked for a while and I didn't get to the bottom of it. I don't know. You know, people don't talk about capture groups very effectively in most of the regular expression references. They mention them in passing, but they don't, you know. So I don't know whether in fact these repetitions of the groups are not allowed or what, but they didn't work for this crate. Anyway, so that's that, and we just ran through all of those. So, you know, and it's just what's here, same stuff. So here's some of the syntax. Not all of it, but some of it. Dot is any character except a new line. Now, let me tell you that there are 4 or 5 variations on regular expression syntax. By far the most common is the Perl version, the version that Perl uses. I think Linux grep is mostly Perl, but makes a few things on its own. There's things called look ahead and look behind, which this crate doesn't implement. So Perl does implement look aheads and look behinds, but this crate doesn't implement them. They say clearly that they don't. So, so there's several variations around in the references, you know. I think one of the references points it out. So anyway, dot is any character except a new line. /d is a digit, single digit. /d is not a digit, anything except a digit. /s, white space, /S, not white space. /w, a character in a word. That is a contiguous group of characters. /w, not a word character, like ampersand. XYZ, character class matching either X or Y or Z. There's only one, not 3 here. Only one. Not XYZ, character class matching any character except X, Y, or Z. B to Q, character class matching any character in the BQ range, inclusive, so it matches B and it matches Q. And here, 0 to 7 and not 4 matches any character in the range. These are digit characters, of course, 0 to 7 except for 4. Any 2 written this way, XY, is a concatenation, X followed by Y. An alternation, either X or Y. X star is 0 or more of X. X plus is 1 or more of X. X question mark is 0 or 1 of X. X in parens is n repetitions of X. And I didn't include it here in the table. I probably should have since I used an example. but X brace n comma n brace m brace is repetitions from m to n. That's what I used in the example I showed you. Mike, if you remember, just in Discord, just send me a little note to add X brace n comma m brace to my table, my syntax table.
Yep.
Thanks. Hat means the beginning of the text. So hat means not if it isn't at the beginning of your expression. But if it's at the beginning of your pattern expression, then it means the beginning of the text. So that the matching text has to match right at the beginning of the string. And dollar has to match at the end. And this is a capture group where dot, dot, dot means anything. Okay? And it's more complete, you know. This is the crate syntax. And he's got, you know, he's got some more stuff you can look at. But these are the ones that I've used mostly. So, and here's a few little tiny examples. Not a lot, but A to Z matches C in a capital letter, this C. And Rust matches any string containing Rust, and so on. Just a few little tiny ones. And this tutorial is kind of nice. If you scroll down, oh, come on. Somewhere here there's a link to the back reference is not implemented by our crate. Look ahead is not implemented by our crate. Somewhere he's got a link to a little playground.
There is try it next to each and every example, Professor. Probably those are it.
Where is it above?
Yeah, almost next to almost every example, right? You have the try it option.
Oh, yeah, thank you.
Yeah.
Try it, yeah. Yeah, so, you know, it's here, and you can change it, you know. So I could say, RD, and now it says, here's what I matched, and I could say RGD, and it doesn't match anything, so, yeah. Okay. So really all we need is match for this for you know this next implementation. And I have some references that I like, you know, for regular expression syntax and regex, you know, for the regex crate. And Jeff Atwood has a nice blog. He's one of the two guys who founded Stack Overflow. And here's where I got the quote from. I'd heard the quote before, but, you know. But anyway, and this is just kind of setting the stage. He's telling you his attitude toward regular expressions and when they're properly used and not. You know, and he's got some good. Some of the references I'm using came from him. So,
Dr. Fawcett,
yeah.
it doesn't, did you, do you intend to put that Rust byte under the list of bytes in the byte section of that? Because I was looking for it there to go and pop it up for your reminder. And I don't see it there yet. Maybe you do.
Okay, hang on a minute. Let me, first of all, let me make sure I put it in the, so, what is going on? There's regular expression in the table of contents,
Yep.
and I
see.
did mean to put it in the, um, you're right, I didn't. Would you add that
Sure.
to my to-do list?
Yep.
Okay. So, uh, so now I'm ready to do a little bit of threading if you want to do that. If you're tired, if you're, hey, I've had enough, we can do all the threading next time. Threading is a bigger slog than regular expression, so I thought I would do a little part of it, the beginning part of it. Is that everybody up for that or not?
Yes,
Perfectly,
Professor.
Yes.
perfectly okay to say no, or either way. Okay, so it looks like we're up for a little bit of threads.
Mhm.
So what's here in the threads? I'm going to talk a little bit about uh, interior immutability and an example, and I probably won't go further than that. Interior immutability is what makes threading work. Without interior immutability, you couldn't do much useful with threads. Interior immutability is we talked about it a little bit when we talked about safety, and you've probably forgotten. But the invariant that Rust uses to check for unsafe code, it doesn't allow, to ensure your code is safe, it doesn't allow shared mutability. And at compile time, it tries to determine that from scope. And there's some places where, the real invariant is no simultaneous shared mutability. I'll never move out from under a reference a value. Okay, so if I don't use that, I can move. The point is that if I created an immutable reference now and use it, now I can create a mutable reference and use it. As long as I don't ever use that immutable reference again, it'll compile. But if I try to use the immutable reference after mutating it, I've changed what was underneath that first immutable pointer, and it will fail to compile. And that can be a little mind-bending when everything compiles, and then you add a statement, and then it fails to compile up above in the code that compiled before. And it's just because the violation is in the use, not in the, where the violation happens is where you declare it, but the actual occurrence of the violation happens when you use it. So in threads, what's happening is if we lock a shared something that we're sharing between a couple of threads, then we can't mutate it we can't mutate it and observe it simultaneously. You either have access to it or you don't have access to it, because it's either locked or it's unlocked. So, but the borrow checker can't tell that at compile time. What it's looking for is a mutable reference that's used and then an immutable reference or another mutable reference used after that. So, it's really scope based. It's all based on scope. And what happens in threads is it isn't scope based. This availability isn't based on scope. It's based on locks. So now, what they've done is they have implemented what's called interior immutability. That means I'm going to lie to the compiler about this type being mutable. I'm going to tell the compiler it isn't mutable. But when I'm running, I'm going to mutate it. And there's only one way that can happen. Can't happen in general. It's all based on something called unsafe cell. Unsafe cell. So here's this diagram. Unsafe cell. What unsafe cell does is allow you to mutate an immutable object. It's unsafe. That's unsafe cell type has an unsafe block that holds the T, and all bets are off. I can do anything I want in that unsafe cell. Now, these guys, cell and ref cell, are wrapping this unsafe cell. It's unsafe for you and I to use this. But these guys wrap it and call it in such a way that these guys are safe. That's been very thoroughly vetted. This one's easy because all cell does is move in and move out. It doesn't hand out references. But ref cell hands out references. So we'll see a little bit of that, how that works. So this is interior immutability. And that only works if the types that you're trying to mutate are wrapped in ref cell, which in turn wraps unsafe cell. Doesn't work for any other type. So
Dr. Fawcett, I'm sorry. Does that correlate to any particular design pattern from the past that we'd recognize? It looks like it might have some relevance. Is there anything that pops up?
No, not really.
Okay.
Not that I know of.
Okay.
So I've got an example of both no interior immutability and interior immutability. And I'm gonna, let's just pull up the code in the playground. Okay, now in the may fail to build function, what I'm doing is I have this mutable value x, and I create an immutable reference to it, and I can and use it. Now I create a mutable reference to it and use it, and this will compile as long as I don't try to use Rx again. You just saw it compile. But let's comment this out. Let's uncomment this out. So now I'm going to use it again. And you can see immutable borrow here, immutable borrow here. What's happened is now it saw that I tried to use a immutable reference after having mutated what it points to. So it's unhappy with that. So this will fail to build if I use, if I break the rules by use. Again, the rules, you don't violate the rule, you only violate the rule by use. You don't violate a rule by declaration, you violate the rule by use. That makes sense? Okay, you see me right here. I've declared them. I've declared an immutable reference. I've declared a mutable reference. Okay, and the rules say that's not allowed. And it's not allowed if I try to use this guy, the immutable reference. Or, if I declared another mutable reference, okay, as long as I didn't use either of these again, it would let me get away with that. Now let's look at may fail to run at runtime. May fail to runtime. So here, now I let x equal ref cell of new. By the way, let me back up just for a second. There is absolutely nothing unsafe about mutating this integer, immutably and immutably, violating those rules. There's really nothing unsafe about that. The issue is that if I have types that are move types, not copy types, then that's definitely unsafe. And in order to avoid the compiler, sorting those out at compile time would slow down the compiler a little bit, and they're trying not to do that. And B, you don't need to use references with integers. The integer is just as small as the reference. So you might as well just use the reference of the integers themselves. Okay. So now let's look at may fail to run fail to runtime. So we saw that this doesn't fail. But now let's look at what's happened. Here's ref cell. And notice that I didn't declare this to be mutable.
Mhm.
I printed it, and displaying it. In order to display it, I've got to call x dot into inner, which consumes this ref cell. So now the ref cell is invalid. So I just recreate it again. Here's x ref cell. Now I'm going to borrow it immutably and display it. Now I'm going to drop it, and I'll talk about that in a minute. Now I'm going to borrow it mutably, and here x dot borrow mute reference, I'm dereferencing it, plus equals 1. So I've just mutated the interior of that immutable object x with this borrow mute. But watch what happens when I remove this drop. Panic! What ref cell is doing, ref cell doesn't let you violate the rules. Ref cell is checking that the rules are satisfied at runtime. The compile time checker isn't able to determine whether it's going to be safe or not safe at runtime, and so it fails it. But ref cell checks it in a very simple way. It has a borrow element. We'll look at that in a minute. It has a borrow element, and it's just keeping track of what's been borrowed. And if something has been borrowed, then it'll, that violates the rules, then it panics. But what happens here with a drop is this borrow returns a type called ref. I guess it's just ref, capital REF. It's a wrapper around this pointer, and it implements the trait deref, meaning anytime I use it like the pointer, it just automatically derefs. Borrow mute is a returns a ref mute type that automatically dereferences to the mutable reference. And so that allows me to reference it. So what happens here is the compiler never sees this type as being mutable, and so it'll pass the compilation. But this drop is necessary because I'm still not allowed to violate the rules. And if I don't drop Rx, I'm violating the rules because now I have an immutable reference and a mutable reference both being used. I'm changing, this guy is changing what Rx is looking at. So if I don't drop Rx, it's changing. Now, drops for anything that isn't a ref cell don't do anything. Up here, I had a drop, and if you uncomment it, if you uncomment this print so it'll fail to compile, and then uncomment this drop, you'll see it'll still fail to compile because for ordinary types, drop doesn't do anything to a reference.
Professor, can you just uncomment the print statement and comment the mrx plus equal to 1?
So what do you want me to do?
Can you comment that line, 21st line, and uncomment line 26?
So let me see what we did. So you're saying I haven't actually used it, so it should pass.
Right, Professor.
Yeah, let's see. And it didn't. That's
Okay.
What's going on here is this is what's this use being the violation, not reference, is something called non-lexical scope that was added to the borrow checker in version 1. But it's not perfect. Remember when we talked about safety, we said here's here's the boundary that the borrow checker does. Here's the real boundary between safe and unsafe code. And this space in between, it gets very hard to evaluate that real boundary. In fact, it's uncomputable. Okay. So there's places where it, would take an infinite amount of time. And so what's going on here is that they are being as forgiving as they can without getting too complicated. But it's not perfect. And what you put your finger on is an inconsistency. So I'm using this rule. The use is the violation, not the declaration.
So can we say that if we do an immutable borrow, it's basically locking the resource?
Hang on a minute. Let me just put this back where it was. So can we say what?
Can we say that if we are doing an immutable borrow, we are technically locking the resource?
No, I mean we're changing it. But anytime you have a borrow of any kind, the owner can't change it. And anytime you have an immutable borrow and then declare a mutable borrow and use it, you can't then use the immutable borrow because you've changed. The reason you can use the mutable borrow is that he's changing it himself. But the rule is I'm not allowed to change something underneath somebody else if they're going to look at it again. Okay? But, you know, these rules aren't, you know, this is an approximation to reality. They're doing the best they can to make allow the compiler to be reasonably fast. And, you know, they're always erring on the side of failing the build if they can't be sure. And I've never, in a year and a half of writing Rust code, I've never found a time when I couldn't do what I wanted to do. I couldn't always do it in the C++ way, but I could always do it. Like building a linked list or a graph class is very difficult in Rust, enormously difficult in Rust, unless you put all the nodes in a vector and then get the relationships by indexing. That's easy. So, okay. So that's, you know, that's what, you know, the idea is. This is giving you a flavor of what interior immutability is buying you, and it's all about refcell. Refcell uses unsafe cell in its interior. So here is a little bit of definition of the refcell. We can see it going on. So here's the refcell. And it has a variable called borrow, which is a cell. And what it's doing is, here's where it's remembering what's been borrowed. It's really the type. Okay. If what's been borrowed is a mutable borrow, any other attempt to borrow will panic. And if it's a mutable borrow, and any attempt to do a unmutable borrow will panic. But if I drop this, what happens is when I drop it, this guy gets cleared. That's why dropping it worked. That's why dropping worked on the ref cell and doesn't work on anything else. It doesn't work at compile time, but it works here at runtime. And then, you know, so here, what's happening here? Here's the borrow mute, and it takes an immutable reference to self. It's telling the compiler, I'm not going to change this guy. But he's returning this type, ref mute, which dereferences down here. Here's the deref mute for this ref mute, this dereference. This is a trait that, you know, anytime I want to, if I try to use a ref mute like a reference, it automatically dereferences it, and what it returns is a mutable reference. So I've lied to the compiler. I've told them here, I'm not going to mutate it with my borrow mute, and then I let my client mutate it. So it's my obligation now to correct that lie by implementing runtime checks. And that's what he does. So ref cell tracks references along at runtime using his borrow member to remember the current state. You know, is this what we just looked at? Is this different? Oh, this is, you know, a little more of the same family of ideas. We're not going to look at it now. You're invited to go look at it. And if you got any questions about it, ask me. It's just reinforcing the fact that, you know, you're borrowing it immutably, but then mutating it. So I think I'm going to stop here. Next time we'll cover basic threads. And here's a very basic, real quick little example. And then this is basically two threads sharing an atomic and a console, and they're both thread safe. So that keeps the example simple. And then the next example shows sharing a non-thread safe object. So here we're going to share a string. Main writes 0 into the string. The first child writes 1 into the string. The second child writes 2 into the string, just appending it. And so you can see here they're definitely sharing that string. And and basically what's happening is they're getting wrapped in a mutex, and mutex holds a ref cell. So the mutex implements interior immutability. That's why this works. And we'll talk about that next time. And then I've got a little thread result. This is just like a C++ feature that allows you to wait on, so a thread is computing a result, and it allows the main thread that created that task to wait for it to finish. Normally he'll go off and do something, and then when he comes back, he'll call get, and he'll just block. But there's also a function that lets me just poll it, and that's what I'm doing here. So we'll talk about that, and we'll talk a little bit about blocking queue, and then we'll be done with threads. And now, for the threads part, we get into building this. So this is not the next 2 weeks, but the 2 weeks after that, we'll take our text search and we'll implement some kind of parallel process like that using the ideas that we've begun to talk about today, and we'll finish talking about in 2 weeks. Okay? Any questions? How we doing? Nooper, you feeling good about the contents?
Yes.
What else could you say?
Professor, are we going to discuss the ref cell, how to link it to threads the next time, or?
Are we gonna, I'm sorry, I didn't hear all of that.
So I'm having trouble linking, like I understand the ref cell part we discussed now, but I'm having trouble linking it to how it will work with threads, like how?
Just like this. So we're going to use mutex, and we're going to say, let's share it equal arc new mutex of new. We're using ref cell right here because ref cell is part of mutex.
Okay.
Okay. So all of the locks and the atomics are based on ref cell, unsafe cell,
Okay.
All right.
Okay.
So you don't, if you find yourself directly using ref cell, you're probably doing the wrong thing.
Oh, okay.
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 If I were forced to write a linked list using references, I would use ref cell.
Okay.
But I would protest. If this was I'm sitting in an interview and the interviewer is saying, okay, write a linked list and use references, I'd say, well, I can do that using ref cell, but boy, that's way harder than just dropping the nodes of the list into a vector and then just doing it, and he would either smile and say, yeah, okay, you passed that question, or he would grumble at me because he didn't really understand, and make me do it. So, or maybe he just wanted to torture me, maybe he understood, but he wanted to torture me and see what I did under pressure. So, all righty.
Yep. Thank you.
Yeah. So I think we're about done. Any questions left? And you guys who are going to put notes to me in Discord have done so, or will do so as soon as we shut off, right?
Have done so, Doc.
Fantastic. Okay. All righty. I hope we'll see you all next time. We'll be in 2 weeks, same time, same place. we'll be doing threads and getting ready to do a parallel. And I got to tell you, I haven't implemented my parallel. I've implemented the uh, regular expressions, but I haven't implemented. I've implemented lots of parallel processing in Rust and other places, but for TextFinder, I haven't implemented this parallel. I haven't implemented this yet. And I don't think there's going to be a huge amount of trouble. My intent is to use my thread pool here. And the thread pool is just a short hop from the blocking queue. We'll talk about the blocking queue, and I'll probably point to the thread pool. And, but what I expect is that if I am searching directories with a whole lot of small files, the parallel processing will probably be slower. If I'm processing, just because the code is a little more complex and there's a little bit of time lost to the context switching. There isn't much context switching. The whole idea of having these, the thread pool is that you're cutting way down on context switching, but there'll be times when there's no thread available, and it's still not really context switching, but you're waiting. Some of those requests are waiting in this queue. But for big files, these guys are going to take a lot longer. And I think for when I'm searching directories that have some large files in them, then there'll definitely be a speed up. Probably about 4 to 1, somewhere between 4 and 8 to 1, because if you have 4 cores on your machine or 4 hyper-threaded cores on your machine, it's like you have 8, close to having 8 cores. So, all righty. I'm done unless there are any final comments or issues. So,
No, thank you.
okay,
Thanks, Doc.
Okay, we'll see you guys. So I'm about to stop recording.